What if I told you that the moon, the glowing companion of our night sky, formed not over millions of years, but in just a matter of hours? New NASA and Durham University simulations have turned one of science's biggest questions on its head. Forget slow and steady, this is the story of a violent cosmic collision and the birth of our moon faster than you could imagine. Let's rewind 4.5 billion years. The Earth was still a young, molten world, fresh out of formation. But then, something happened. A protoplanet the size of Mars named Theia crashed into Earth in what's called the giant impact hypothesis, or the Big Splash. Theia wasn't just a little bump, this was a catastrophic, high-speed collision. Scientists calculate that Theia struck Earth at 9.8 kilometers per second, that's over 35,000 kilometers per hour at an angle of roughly 45 degrees. The collision released unimaginable energy, vaporizing parts of both Earth and Theia and creating a huge debris field. Over time, this material came together through gravity to form our moon, at least, that's what scientists thought for decades. The traditional theory suggested the debris took millions of years to settle into a single body, the moon. But what if that's wrong? Enter NASA and Durham University's ultra-detailed supercomputer simulations. Using some of the highest resolution models ever run for studying giant impacts, scientists discovered something incredible. The moon might not have taken millions of years to form. Instead, it could have formed in just a few hours. Here's how. The collision launched material straight into orbit, not just a chaotic cloud of debris, but a disk of molten rock and vapor. In these simulations, the gravitational forces of this material caused it to clump together almost instantly. Within hours, the moon was born. Think about that. A single, catastrophic impact boom, and within hours, a massive, rocky body starts to take shape right next to Earth. It's mind-blowing. So, why does this matter? First, it changes everything we know about planetary formation. If the moon could form this quickly, it means other moons and planets might form faster than we thought, too. Second, the simulations might explain why the moon and Earth are so chemically similar. A fast-forming moon would preserve more of Earth's original material, matching what scientists have found in lunar rocks. In fact, samples brought back during the Apollo missions show that Earth and the moon share nearly identical isotopic fingerprints. This new theory fits that puzzle perfectly. But what actually happened moments after the impact? Scientists believe the collision created an intense shockwave that wrapped around Earth within hours. Huge chunks of molten rock and vaporized material shot into space, forming what's called a synestia, a giant, donut-shaped cloud of vaporized rock. In this spinning cloud, gravity quickly worked its magic. Heavier material clumped together, and as the debris cooled, it formed a solid, spherical body, the moon. The idea of such an instant moon challenges everything we thought we knew about slow, steady planetary processes. If these simulations prove correct, it's one of the most groundbreaking discoveries about our cosmic backyard. A giant, catastrophic collision, and a moon that formed not over eons, but hours. The next time you look up at the moon, just imagine, it's not just a peaceful light in the sky. It's a scar, a survivor of the most violent event in Earth's history, and it might have come together in the blink of an eye.